When creating a new variable or data structure, it's become very common for modern programmers to allocate memory for those individual objects one by one. In languages like C++ and C#, you do this explicitly by using the new keyword. And in languages like Python and JavaScript, it happens automatically for you whenever you declare an object or a list or an array or that type of thing. While this approach is initially quite convenient, the problem is that in languages like C and C++, allocating memory for individual objects means that you have to remember to correctly deallocate each of those individual objects later. And unfortunately, because programmers aren't perfect, this can lead to memory leaks or crashes or security bugs. So a number of modern languages like Python and JavaScript and C# solve this problem using something called garbage collection, which is essentially where a little program runs in the background of the program that you wrote, keeps track of everything you allocate, figures out when your objects aren't being used anymore, and automatically deallocates them for you. So you don't have to think about it, and you can't screw it up. Sounds great on paper, but there's always a catch, right? As it turns out, the problem with garbage collection is that it's quite slow and also very memory intensive, especially when you have a large application that allocates lots of small objects. So for high-performance applications like AAA games or embedded real-time systems, you're probably going to choose to use a programming language that doesn't have a garbage collector. But a garbage collector isn't the only way to solve this problem with individual allocations. One of the best tools that we have at our disposal is something called a memory arena, or just an arena for short. Arenas might sound intimidating, but they're actually very simple. Instead of allocating lots of individual objects one by one, you allocate a big chunk of memory called an arena up front, put a whole bunch of smaller objects inside it, and then when you're done with it, instead of having to deallocate each object individually, you just deallocate the arena and you're done. Super simple. No worries about forgetting or messing up individual deallocations, and it's actually significantly faster than allocating lots of small objects anyway. And the best part is, if you've done any programming at all, no matter your programming language background or skill level, not only do you already understand this concept of an arena, but you're already using it. Because every time you call a function, you're actually using an arena. Take this function that calculates the price of an item. When you declare a local variable inside a function like the total price here, you already know that the variable is going to disappear when the function returns. It'll be deallocated. If you declare 2 or 3 or 100 local variables, they'll all be deallocated together at the same time when the function ends, because that's how local variables work. Every function call actually creates an arena on the stack that contains all the data that it needs. The function arguments, the local variables, the return address, it's all in there in one chunk of memory. The functions arena actually has a special name. It's called a stack frame, but it's still an arena because the memory for the stack frame gets allocated all together when the function's called, and then deallocated all together when the function returns. Imagine if you had to remember to deallocate every local variable in every function. It would be such a pain, and eventually you would forget and create a memory leak. Now, a stack frame is an arena that's built into the programming language, but you can also get amazing benefits from creating and using your own custom arenas. Let's look at a real-world use case. Say you're writing a backend web server. When a browser makes an HTTP request and connects to your server, you'll need to create and process data specifically related to that one request. A string buffer to hold the request as it comes in. You'll need to convert that string to a data representation, make SQL queries, connections to other backend services. You'll need another string buffer to actually write the response into so you can send it back to the client. But then after you've sent the response and the request is complete, you won't need any of that data anymore. So rather than having to remember to deallocate all of those objects individually at the correct time or rely on a garbage collector, you can just create an arena specifically for processing that one HTTP request. Put everything related to the request into that arena, and then after you've successfully sent the response, you can just deallocate the whole arena in one go, and you've cleaned up everything efficiently with no leaks. A good general rule of thumb with arenas is if you can see that you have a significant amount of data that's related to one specific task, and when that task finishes, you're expecting to delete all that data, you can use an arena to make your life much simpler and make your program much faster. I won't go into the specifics of implementing an arena in this video because it differs depending on your programming language of choice, but rest assured it's very simple and straightforward to implement. So give it a try in one of your projects.